Look at this water. It is violently boiling right now. There is no fire under this beaker, no stove, and no heat source whatsoever. Instead, this water is being forced to boil using nothing but a silent, invisible sound wave. In everyday life, boiling is just a game of thermal kinetic energy. At room temperature, the invisible air pressure around us is constantly pushing down on the liquid, keeping all these water molecules locked tightly together in a fluid state. When you turn on your stove, you are forcing heat energy into the water, causing these molecules to vibrate faster and faster. Eventually, at 100 degrees Celsius, they are moving so violently that they break free from each other's grip, turn into steam, and float away. That's basic kitchen chemistry, where you add heat to overpower the pressure. The bonds break, and the water boils. But adding heat is not the only way to make it boil. See, chemistry tells us that a phase change depends on two factors: temperature and pressure. Instead of increasing temperature, you can boil water by decreasing the pressure. And that's exactly where sound waves come in. Sound isn't just something you hear. It's a physical and mechanical wave of pressure moving through space. It has two distinct parts: a high-pressure cycle called compression and a low-pressure cycle called rarefaction. When sound waves passes through water molecules, high-pressure cycle compresses the molecules, while low-pressure cycle make these molecules expand. In this way, water molecules propagates. If you make this sound wave incredibly loud and fast, that low-pressure pull becomes so overpowering that the local pressure drops below the water's vapor pressure. As a result, the sound wave creates the microscopic hole in water and increases its temperature. This mind-bending phenomenon is called acoustic cavitation. Because there is no actual heat keeping this bubble stable, it lives on borrowed time. The moment the sound wave shifts back to its high-pressure compression cycle, the surrounding water violently squeezes the bubble from all sides. When it completely collapses, the matter inside is compressed so violently that for a split second, temperatures spike to over 4,700 degrees Celsius, which is nearly as hot as the surface of the sun. This raises the overall water temperature, causing it to boil. Now, this might sound like a cool laboratory physics trick, but in the real world, this invisible sound phenomenon is an absolute disaster. And the British Royal Navy had to learn that the hard way. In 1894, they built a brand new ship called the HMS Daring. It was designed to be the fastest boat in the world. But during its first high-speed sea trials, something completely bizarre happened. When engineers pushed the engines to full throttle, the ship didn't speed up. Instead, the propellers just thrashed the water wildly. The boat lost thrust, and the whole ship started shaking so violently, it felt like it was going to tear itself apart. When they pulled the ship into dry dock to see what went wrong, the engineers were horrified. The solid metal propeller blades were covered in deep, jagged craters. The spinning of the propeller blades through the water was creating localized high-intensity pressure waves. In other words, it was triggering acoustic cavitation. Every single second, millions of these tiny vacuum bubbles ripped open and slammed right into the metal. The collapses were so violent, they acted like microscopic jackhammers that blast the solid steel away. From the mysterious damage on those 19th century naval ships to modern engineering labs, acoustic cavitation shows us a beautiful hidden side of physics and chemistry. It proves that you don't need a massive fire or a giant furnace to alter a material's phase. If you have the right frequency and the right pressure, you can tear a liquid world apart using nothing but sound. The next time you see bubbles forming in a simple glass of water, remember that under the right conditions, those tiny pockets can get hotter than a star. Thanks for watching. Make sure to hit that subscribe button for more deep dives into the simple science of our world. I'll see you in the next one.